Hello folks, this video goes over the chapter 5 study guide for the entire chapter, so not just the second half, but kind of a recap of everything. Let's jump right in. Number 1, it says change 47.283 degrees to degrees, minutes, and seconds. So recall there's actually a function for this in your calculator. Of course you could do it by hand, but since you have access to the calculator, basically you will use the second angle button. And then number 4 says DMS, literally degrees, minutes, and seconds. So if you type it in exactly as you see it, hit second angle number 4, you should get 47 degrees, which that's obvious because we knew that. 47 degrees, 16 minutes, and 58.8 seconds. Number 2 goes backwards. I give you degrees, minutes, and seconds, and I ask you for the decimal to the nearest thousandth of a degree. So for this one, there is no quick function. You literally just have to type in this expression exactly as you see it. Using the second angle option, 1 and 2 give you the degrees and the minutes, and then you also will have to use the the alpha plus button. That's not an eraser. There we go. The alpha plus button to type in the seconds. So when you do that, you would get 122.72 degrees. Number 3, it says give the angle measure represented by 2.25 rotations counterclockwise. Remember, counterclockwise is our default direction, so it's going to be 2.25 times a positive 360 degrees, which will give us 810 degrees. Number 4, identify all coterminal angles for 480 degrees, then give one negative. All coterminal angles. So recall, coterminal angles both start in standard position, but where this one may just rotate, 70 or something degrees to look like this angle could rotate the full 360 and then a 70 degree and then stop there. So they have the same stopping point, but this one here made another 360 degrees. So the idea is that there are an infinite amount of coterminal angles. So I cannot write them all down because we would never stop writing. But we can represent all coterminal angles by doing 480 degrees plus 360k degrees, where k represents integers, and that can be positive or negative, so that'll go clockwise or counterclockwise. Now, one negative coterminal angle, so if I just start at 480, subtract 360, doing that is not going to be enough. We're still going to have a positive number, so I'm essentially going to have to subtract a full 720, and then I will get a negative 240 degrees. And that one's just an example. You could give me a lot smaller negative number if you'd like. Number 5, how do you determine an angle's reference angle? So you could tell me in words, but essentially what I'm looking for here is just a chart. So if you recall, if an angle is in the first quadrant, its reference angle is itself, alpha. So that's what we want. If it's in any of the other quadrants, we need to get it, basically, if this is my angle here, I need to figure out what angle in all of the other quadrants that are going to be between the angle and the x-axis has to be the same. So here, obviously it's already alpha. Then I got to figure out how do I get that. Then in the third quadrant, I've got to figure out what this angle is. In the fourth quadrant, I've got to figure out what this angle is. Okay, and to do so, it's just going to involve a little bit of subtraction. So in the second quadrant, we're going to subtract 180 minus alpha, and that'll give us that angle. In the third quadrant, that's going to be alpha minus 180. And in the fourth quadrant, it'll be 360 minus alpha. So those 4 red angles will all have the same coordinate points, but different signs because of their quadrants. Number 6, determine the reference angle. So now we're actually going to use this chart. So for part A, 323 degrees. So first we need to recognize that this angle is in the 4th quadrant. So we're going to subtract 360 minus 323, and we'll get a reference angle of 37 degrees. Part B, 17 degrees, is already in the 1st quadrant, which means it is its own reference angle, 17 degrees. Part C, 224 degrees, is in the 3rd quadrant, so we will subtract 224 minus 180 and end up with 44 degrees. And part D, 95, is in quadrant 2, so we will subtract 180 minus 95, which is 85 degrees. Number 7, in triangle ABC, where A is 3 and B is 5 and C is the hypotenuse, find the value for the following. So a couple things. When I use the term hypotenuse, I'm giving away that this is a right triangle. There's not a hypotenuse in any other types of triangles. So I know that when I draw my sketch, it's going to be a right triangle. C is the hypotenuse, which must mean that this angle, C, is the 90-degree angle. And then it doesn't specify where A and B are, which means it doesn't matter where you put them. So I'm just going to choose to put A here as a side length of 3, which must mean this is angle A. And so my other angle must be B, and across from it will be side B, which is 5. So now let's actually set up our ratios. The sine of A. Sine is found by, you could do y over r if you recognize, like maybe trying to fit this into a circle, but you could also go back to your regular SOHCAHTOA. Sine is opposite over hypotenuse. So opposite of angle A is 3, but I don't have my hypotenuse. So we need to go off to the side, and we'll use Pythagorean theorem. 3 squared plus 5 squared equals c squared. 3 squared plus 5, oh, what is all that? Oh, shoot. Oh, technology. 99999. That's the answer. Just kidding. There's another one. Man, I was getting pretty good at this tablet stuff. Alright, let's try it again. What was that? 3 squared plus 5 squared equals c squared. 3 squared plus 5 squared is 34. 34 is equal to c squared. So then c is going to equal the square root of 34, which there are no square numbers that divide evenly into 34. So that's as small as it can go. So for the sine, when I put 3 over the hypotenuse is the square root of 34. Remember, we can't have radicals in the denominator, so I'm going to rationalize this by multiplying by the square root of 34 over the square root of 34. And when we multiply straight across, we get 3 square roots of 34 over 34. And 3 over 34 does not simplify, so that's as small as we can go. Cotangent of B. So if you recall, tangent is opposite over adjacent, therefore cotangent is adjacent over opposite. This time our reference angle is from B. So if I use from reference angle B, adjacent to that is 3. Opposite of angle B is 5. So 3/5. And then the cosecant, remember cosecant pairs with sine, as weird as that is, which is opposite over hypotenuse. Therefore, cosecant is hypotenuse over opposite. So that's going to be the square root of 34. Remember, we're now using angle A as a reference, so opposite of angle A is 3. So there's your ratio. Number 8, if the secant of theta is equal to -1/2, what is the cosine of theta? Now, you could do a couple things. You could draw yourself a picture, set up your ratio, all that kind of, or set up the legs of the triangles and stuff. But if you just remember that secant and cosine are inverses of one another, not inverses, reciprocals of one another, then all we need to do is take the reciprocal of negative 1/2, which is negative 2 over 1, which is just essentially negative 2. Now, numbers 9 through 11, it says use what you know about the unit circle to determine exact values for each of the following. A hint that I want you to take is to find the reference angle first. Find the reference angle first. So for number 9, the sine of 135 degrees. Now, unless you have your entire unit circle in your brain to where you can just, the coordinate point for 135 is stored up in there, and then you can grab that and then you're good to go. Typically, what happens is we have the first quadrant memorized. So, or, we know how to generate that using our special right rules. So for 135, if I go ahead and say, okay, I know 135 degrees is in the second quadrant. So if I'm going to find that reference angle, then I'm going to take 180 minus 135, and I'm going to get 45. Okay, so what that means is, now I'm going to use what I remember about my 45-degree angle. I remember that the coordinates at 45 degrees are the square root of 2 over 2 and the square root of 2 over 2. The only difference is that this implies that my 135-degree angle, because it is in quadrant 2, is that my 135-degree coordinates are going to have a negative square root of 2 over 2, positive square root of 2 over 2, because in the second quadrant, my x's are negative. So now I'm going to use that info to find the sine of 135. Well, if you recall, the sine is y over r. Well, again, we're in the unit circle, so we know that r is definitely going to be 1, so all I need is my y value, which is this. Therefore, the sine of 135 degrees equals the square root of 2 over 2. Number 10, the cosine of 210 degrees. So again, let's find our reference angle first. 210 is in the third quadrant. Therefore, we're going to subtract 210 minus, backwards. No, that's right. 210 minus 180, which is going to be 30 degrees. So we know 30 degrees, or hopefully we know, that 30 degrees has the coordinates square root of 3 over 2, 1/2. So what that means, or that implies, that our 210-degree angle is going to have the same coordinates, except since it's in the third quadrant, both of these coordinates are going to be negative. So negative square root of 3 over 2, negative 1/2. Therefore, if you recall that the cosine is x over r, again, we know the radius is 1, so we're just looking for the x value. Therefore, the cosine of 210 degrees is equal to negative square root of 3 over 2, just the x value of that coordinate. Lastly, the tangent of 270 degrees. Now, the issue with 270 degrees is that it is literally on the y-axis, right? It is here. So that coordinate point is 0, negative 1. So when I ask you for the tangent, tangent is found by comparing either opposite over adjacent, right? But, and using the circular coordinates here, that'll be y, the circular functions, that'll be y over x. Well, y over x is negative 1 over 0. Division by 0 is going to get us an undefined answer. Moving right along, number 12, find the value of secant of theta for an angle theta in standard position if the point 4, negative 5 lies on its terminal side. So let's first go ahead and kind of sketch out 4, negative 5 is going to be in the fourth quadrant. So if I sketch up my x and y axis and say, okay, I'm going to go out to the right 4, and then down 5, that'll be negative 5. And then, of course, everything is going to be a right triangle in this scenario. So let's call that angle theta. Now it says find the value of the secant. So recall secant of theta. Secant is paired with cosine, and if cosine is x over r, then that means the secant of theta is r over x. So we know the x value already is 4, but we need the radius value. So in order to do that, we need to use the Pythagorean theorem to solve for our hypotenuse. So we're going to do 4 squared plus negative 5 squared equals r squared. So 4 squared plus negative 5 squared, remember to put that negative 5 in parentheses, so that'll be a positive 25 plus 16, which is 41. So r is equal to the square root of 41, which can't be simplified any more than that. So our secant of theta is going to be the radius is the square root of 41 over the x value is 4. Number 13, suppose theta is an angle in standard position whose terminal side lies in quadrant 3. If the tangent of theta is 5/12, find the sine of theta. So this time, it's a very similar question, but instead of telling you the coordinate point, the fact that it's in quadrant 3 gives away the signs. So quadrant 3, I'm going to have a scenario like this, and we don't really know where it ends per se, but we know it's going to make a right triangle. So you can just almost put any kind of hypotenuse there. Call that theta. We know that's 90 degrees. Okay, so from theta, it says we know the tangent is 5/12. Now, tangent, excuse me, tangent is either y over x, right? Rise over run, your slope, or it is opposite over adjacent, however you want to think about it. So the y value, now remember, because I'm in quadrant 3, even though it says it is 5/12 in quadrant 3, that implies that we're going to have a negative 5 because it went down 5 and negative 12 because it went to the left 12. And then when you divide negative 5 over negative 12, that's why we end up with a positive tangent in that quadrant. Okay, so then it says, or we're trying to find the sine of theta. If we remember that the sine is, you could do opposite over hypotenuse, or you could do y over r, however you want to think about it. Then we, again, need the radius. So let me use Pythagorean theorem. So I'm going to do negative 5 squared plus negative 12 squared equals r squared. And that's going to be 169 equals r squared, which is a grade sign because the square root of 169 is 13. So if the radius is 13, then that implies that the sine of theta equals y over r. So the y value is negative 5 over the radius, which is 13. So negative 5 over 13 is the sine of theta. Number 14, assuming the angles in quadrant 1, evaluate the tangent of the inverse secant of 13/5. So this one always tricks everybody just because they forget how to do it. Essentially what you want to do is you want to kind of define the inner part of this function. So we want to define this inverse secant of 13/5 as alpha. So then if I say, okay, alpha is secant inverse of 13/5, I want to use this information to try and draw a triangle so that I can actually set up that tangent ratio that it's asking for. So if I want to isolate 13/5, the inverse of secant inverse is literally the secant. So if I take the secant of both sides, then I get the secant of alpha is equal to secant of secant inverse cancels 13/5. Okay, now recall secant is paired with cosine, which is adjacent over hypotenuse. Therefore, secant is hypotenuse over adjacent. So I can draw a right triangle. Again, it says it's in quadrant 1, so you know your triangle should look something like this. And if I call this angle here alpha, we know that the hypotenuse is 13. and adjacent to alpha is 5. So then let's go back to the original question. The question now that I've defined alpha is essentially what is the tangent of alpha? Well, tangent is opposite over adjacent, or y over r. So I need to use Pythagorean theorem to solve for that leg. So that'll be 5 squared plus b squared equals 13 squared. So then you're going to end up with b squared is equal to 144, so that b is equal to 12. And if you know these Pythagorean triples, then you don't need to waste your time doing the Pythagorean theorem if you know that that leg is going to be 12. Therefore, the tangent of alpha is going to be opposite over adjacent, which is 12 over 5. Number 15, it says given right triangle ABC, solve the entire triangle if b equals 7 and c equals 12. I should have added into these instructions that c is going to equal the hypotenuse. You are allowed to make that assumption if I add that in the directions, which just assume that I am. So if you know that, then this makes it a little bit easier because you actually know how to draw this scenario. Then that means you're going to have just a right triangle. If c is the hypotenuse, then that means angle C is going to be across from the hypotenuse. So angle C has got to be the 90-degree angle. And we know, again, C is 12. And then the other two angles you can label as you want. I'm just going to label this top one angle A, the bottom right one angle B. And if I know side B is 7, then across from angle B is also 7. So if I ask you to solve it, that means you need to find the rest of the information. Well, we already found the easy one, which is that the angle C is 90 degrees because it's opposite of the hypotenuse. So there's one of your other answers. And then we could find the other leg by doing the Pythagorean theorem. So 7 squared plus a squared equals 12 squared. So then a squared equals 95. So a is equal to the square root of 95. And that can't be simplified, so that is your answer. So that's side A, the square root of 95. So now I need to find my angles, and you could find A or B first. It doesn't matter. I'm going to solve for angle B just because I want to. So I'm going to set up a trig ratio. I'm going to say the sine of B is equal to, and you don't have to use the sign, but I just recognize I want to try to avoid this radical here. Not that it matters, but, you know, just try to keep things simple. The sine of B is opposite over hypotenuse, so opposite of B is 7. The hypotenuse is 12. Now, I want to isolate B. So to get B alone, I need to get rid of sine by doing the sine inverse. And what I do to one side, I've got to do to the other. So if I take sine inverse of both sides, on the left side, those cancel. Well, just the signs, not B. B is still there. So then I get B is equal to, on the right-hand side, sine inverse of 7/12. So you're going to hit second sine of 7/12, and you'll end up with angle B is approximately, I didn't tell you how to round, but typically we've been just doing to the nearest tenth. So that'll be 35.7 degrees. So you've got your three sides, and you've got two angles, so the third angle is going to be easy to find, because then we just need to subtract 180 minus 90, which is 90, and then 90 minus 35.7 to get angle A, which will be about 54.3 degrees. So this is the front side of your study guide, and I'll make a separate video for the back side.